Hey everybody, welcome back to Math 251. In this video, we are going to be talking about the derivatives of sine of x and cosine of x and how we can use those derivatives in order to find the derivatives of some more interesting functions as well. So this theorem 3.8 is straight out of the textbook and it tells us what the derivative of sine of x and cosine of x are. So the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Yeah, so there we have it. Those are the derivatives. And now we can use these derivatives to find other derivatives as well. So let's find the derivative of y equals sine of x times cosine of x. So here we have two functions that are multiplied together, so we are going to have to use the product rule. So remember, the derivative of a function that looks like f of x times g of x, where f of x and g of x are functions, the derivative of this is equal to f prime of x times g of x plus g prime of x times f of x. This is the product rule, which we learned a few lessons ago, and we'll be using that here. So let's go ahead and label our two functions here. I'm going to call f of x sine of x, and I'm going to label g of x cosine of x. And in order to use the product rule here, we also need to find the derivatives of f and g. So f of f prime of x is, according to our rules up here, cosine x. And the derivative of g of x, which is the derivative of cosine x, is equal to negative sine of x. Now we can use the product rule so that y prime is equal to f prime of x, which we found as cosine of x, times g of x, which we found to be cosine x, plus g prime of x, which is negative sine of x, times f of x, which is sine of x. And if we simplify this a little bit, we can say that this is cosine squared of x minus sine squared of x. And this is really close to being a trig identity, but it's not quite there. So this is as simplified as we can leave it. This is our derivative. Let's do another derivative using the quotient rule instead. So here we have the derivative of h of x equals x plus sine of x divided by 3x squared minus cosine of x. So just to remind us, if we have a function that looks like y equals f of x divided by g of x, we have to use the quotient rule so that y prime is equal to g of x times f prime of x minus f of x times g prime of x. All of this divided by g of x squared. So we're going to have to label our functions again here. So here our f of x, which is the numerator in our quotient, is equal to x plus sine of x. And our denominator, g of x, is 3x squared minus cosine x. And now, of course, we need to find the derivatives of both of these. So f prime of x is equal to, well, the derivative of x is equal to 1, and the derivative of sine of x is equal to cosine x. And g prime of x is, the derivative of 3x squared is 6x, and the derivative of cosine x is negative sine of x, so I have minus a negative sine x, and of course we can rewrite this as 6x plus sine x. And now we can employ our quotient rule so that the derivative of h prime of x is equal to g of x, which I found to be 3x squared minus cosine x, 3x squared minus cosine x, times f prime, which is 1 plus cosine x, minus f of x, which is x plus sine x, times g prime of x, which is 6x plus sine x, all of this divided by g of x squared. That's 3x squared minus cosine x quantity squared. So you could leave it like this. This is correct, but let's see if we can simplify this a little bit. This is kind of an optional step, but as a mathematician, I like to simplify as much as I can. So let's go ahead and expand these terms. So 3x squared, if I FOIL this out, 3x squared times 1 is just 3x squared. And then we have 3x squared times cosine x. 3x squared times cosine x minus 1 cosine x minus cosine x squared. Okay, and then I have minus 6x squared x times sine of x. I'm going to run out of room here, but that's okay. And then we have 6x sine x and finally sine of x squared. And we still have all of this divided by 3x squared minus cosine x squared. So now let's see what we can combine here in terms of combining like terms. I have this 3x squared that I can combine with this negative 6x squared to give us negative 3x squared. Let's see, what else do I have? I have a x squared, x sine x and a 6x sine of x that can be combined to 7x sine of x, but remember we have this negative out in front, so that gives us a negative 7x sine x. And then it looks like that's all that I can combine. So we have plus 3x squared cosine x minus cosine x minus cosine squared x, and then we have this minus sine squared of x. All of this over 3x squared minus cosine x quantity squared. And this is our answer. Woohoo! So I'm not sure how simplified Newton-Malta wants your answer. I believe it will take it in this unsimplified version, but if you are curious as to how to simplify this, that is what we just did, combining all of our like terms and expanding out. And this is how we can use the derivatives of sine of x and cosine x.